Okay, so on the photoelectric effect experiment, let's have a little warm up here before we get into taking data. So what I wanted to show you a little bit was some of the key elements of the experiment, how things sort of work together. So over here in this frame here, this side of the frame is the photocathode in the box that I showed you, and the light's coming in from this direction. It's not so important at the moment, but I have a green LED on and I can see the green LED going into the small hole that I showed you in a previous video. Let's focus on the picoammeter, the stopping voltage, and the little power supply as we mentioned here to get warmed up. So here's what we see thus far. Everything's just sort of on. I'm not really doing anything. And according to the picoammeter here, I'm getting about 38 nanoamps of photocurrent. So in other words, nanoamp is a very small unit, but that's sort of a measure of the photocurrent that's coming off of the photocathode, making it over to the anode inside the box here, and sort of traveling through as a circuit. So I can sort of verify this. So what I'll do is I'll just sort of take my hand and cover photocathode up, and you see the current drops very, very low. So something is being stimulated by the light. So there's my hand out again. There's my hand in again. There's my hand out again. So you can see that the photocurrent is definitely something that's coming from the light. So what about this retarding potential now? Well, I have the box on, and what I'm going to do then is, hopefully you can see sort of in the back here that the retarding potential, the black and red leads, are going right into the leads on the back of the box with those pins and those connections that I showed you in a previous video. So we'll just sort of leave that. And this last coaxial cable here is actually connected to the picoammeter. Now the reason why we don't use these black and red patch cords for measuring the current is because the current's very small and it's susceptible to electrical noise that might be in the environment. So it's best to keep that very sensitive current going into the nanoamp meter into a shielded cable, which coaxial cable is. So maybe it's not even shielded as well as it could be, but it seems like it's working okay. So what I'll do now is that's sort of the course setup, and I want to sort of reduce the wiring to show you what's going on. Again, the stopping voltage is connected over here to the pins on that glass tube photocathode. So what I'll do now is I'll just plug in the voltmeter, I'll stack the patch cords together like this so we can actually see what voltage is coming out of the stopping potential. So 0 at the moment, and of course if I turn it up, that's working okay, so we're getting some voltage. So what I want to focus on then, even though the wires are getting in the way a bit, is exactly what this photocurrent is. So at the moment then, you can see all the devices working here, and well, these wires really are in the way. Let me maybe tuck those over like that so you can see the numbers. That's better. Okay, so you can see we're getting about 38 nanoamps of photocurrent. And so what happens now is I start turning up the stopping potential. You can see I'm about 0.06 volts. You can see that actually the photocurrent is going up. So 55, 56, 60, 65 nanoamps. And that's really not what we want to happen. Remember, the stopping potential is supposed to stop those electrons, not sort of make them come off more. And so obviously what is happening now is the electric field produced by this voltage across the cathode and the anode in there is obviously in the wrong direction. So it's sort of, if you think of F is equal to QE, the electric field caused by this potential is obviously pulling electrons off of the photocathode, not forcing them to stay on if they get ejected. And so this is sort of not what we want to happen. So what do we do about that? How come when I turn up the stopping potential, it doesn't seem to be stopping electrons? In fact, it seems to be causing more of them to flow off. Well, it's just a polarity problem. So what I'm going to do then is I'm just going to reverse these two leads on this. I'm going to make the black into the red and the red into the black to reverse that electric field between the cathode and the anode, and hopefully that will stop the electrons. So I'll go ahead and do that now. I'm just going to pull this out and pull this out if I can. There it goes. So the red is into the black, and the black is into the red. And we're okay doing this because, as I mentioned earlier, the stopping potential is just a battery. And so it sort of has its own ground. It's not connected electrically to anything else, say back in the wall or anything. So let's see what happens now. Again, I'm at 0 stopping potential. As I start turning it up now, so you see that photocurrent is going down now. And we'll ignore the minus sign on here because you saw me just reverse the two leads here. So we'll just always read the absolute value of the number. But you see that the photocurrent is going down now. So there's like 8 nanoamps and 7, 6, and so on. It goes down, down, down. And remember, I would like to zero this as much as possible to demonstrate that the stopping potential is indeed stopping electrons from coming off of that photocurrent, and that's what gives me an estimate of the work function of those electrons in the metal. So I'm still going down, getting really slow. So it looks like I just crossed zero because I saw the minus sign sort of pop up. So I'm sort of in there, and maybe we should stop here, but remember this is a picoam meter, and so I can sort of press over here the range button to go to even a more sensitive scale. So if I do that now, I think I picked up an extra digit. So if I go back up again, see I've got 2 digits in front of the decimal, but if I go down again, it sort of puts that digit on the right side of the decimal. So I'm in the most sensitive meter mode now. And so this is what we mean by a picoam meter. It still says nanoamps right there, but because I'm way down in these fractions here, I'm clearly into the picoamp regime. And so let's see how much I can zero it now. There's sort of the positive current, and now I'm negative and getting bigger or something like. So right about there or so is probably about as zero-ish as this is going to get. And so this would sort of be a data point. As you can see then, it looks like 0.884 volts of stopping potential is stopping electrons from leaving that photocathode just about as sort of well as it's gonna. And of course, the other key parameter is what wavelength am I using, but we're not going to worry about that right now. But suffice to say, it's green light. You can see a little bit of a green glow on here. Green light's going in. So I would conclude at this wavelength, this stopping potential is going to be an estimate of the work function of the metal at that wavelength because I've zeroed the current as much as possible. In other words, I'm stopping electrons from coming off that photocathode, so I must be approximating the work function of that electron. And that's essentially where a data point is going to come from. So I'm basically going to record wavelength hitting the photocathode as a function of stopping potential that zeros the current. That's going to be the photoelectric effect experiment. And if I can collect a bunch of wavelengths and a bunch of stopping potentials, that's going to be my raw data set. So again, I hope you can sort of see what's happening here, how all the equipment works together. I have the stopping potential here. I can sort of change the amount of photocurrent that I observe coming off the photocathode. In this case, I'd like to zero it because I'd like to stop those electrons to get an estimate of the work function. And I also saw that the polarity was at least wrong the way it was initially set up because as you saw earlier in the video, as I increased the stopping potential, the electron photocurrent actually went up, and that's not what I want this to do. So I reversed it, and now I think we're all set. So I think we're all set to start taking data.